Hi everyone, my name is Meina Zhou, and today I'm here to talk about how to build a fraud detection system using machine learning models. And before I kick off my session, I would like to first make a self-introduction. I think based on the 10 minutes conversation before the session, you probably have noticed like I'm a consultant and I work on a lot of different client projects. And my current role, I'm a data science manager at Indelian. Indelian is a professional IT services company based in Canada. So we serve a lot of clients across different industries, including technology, multimedia, insurance, and etc. And I'm here because I really love to talk about different data science projects. I've worked on a lot of the different data science projects, including customer churn prediction, upsell prediction, customer journey, customer lifetime value prediction, fraud detection, or even a lot of natural language processing projects. So if you really like to talk about any those projects, please do not hesitate to reach out to me. I have listed out my email here. And you can also add me on LinkedIn if you feel that's more comfortable. My background is mostly in the consulting industry. I've been in the industry for 5 to 6 years. My academic background is that I have a Master of Data Science degree from NYU, and undergraduate is double major in mathematics and economics from Agnes Scott College. Yeah. So now that you know what kind of things I'm working on, I would like to kick off the session. And here is the agenda for today's session. I'm gonna first talk about my understanding of what the current fraud detection industry is focusing on, then talk about our general approach of how to build a fraud detection system. And after that, I'm gonna talk about the key drivers as well as challenges that we have faced when we were building different fraud detection system. And essentially, I will talk about use cases as well as conclude the session with a bunch of key insights that we have gained. Let's get started with a fraud detection overview. So we all know that there are many different kind of fraud detection use cases or categories right now. And I have listed out the three most important, or at least it's from my perspective, what are the most trending fraud detection categories. The first one is called identifying financial transaction frauds. We all know financial institutions or different companies, they will have a lot of transactions worth large amount of money execute across different industries and companies every single second. And then it is really important for them to identify those suspicious activities so that they can reduce fraud losses, speed up investigation, as well as control financial crimes. And then additionally, those financial institutions, they need to comply with government regulation. So legally, they also need to be better and better at identifying those financial transaction fraud. And then the second category I want to talk about is called healthcare claim fraud. So because of COVID-19, I think a lot of healthcare companies are doing pretty well, but they are also facing a lot more healthcare claim fraud. And then even before COVID-19, healthcare fraud and abuse cases have always costed the healthcare industry billions of dollars every year. And it is really imminent for those companies to increase the accuracy and efficiency of their fraud detection system, as well as to improve the medical billing processes. If they increase the efficiency and accuracy of their fraud detection system, this will help them to save a lot of money. And then the third category is called monitoring sensor data fraud. So I think a lot of speakers have talked about IoT data, Internet of Things. And we all know that every day different devices or different machines have been collecting the sensor data, right? We have mobile phones, we have tablets, we have laptops, we even have other devices that have all those different kind of sensors. So we know large volume of sensor data has been generated and recorded across those equipment in real time. And with that large amount of data a lot of companies have actually started to build monitoring systems based on machine learning algorithms to prevent breakdown and disruptions. So simple application could be the IoT data can actually help you to understand how your buildings are managed, those like heating system or those alarm systems. And then you can actually use that to predict or prevent the breakdown of those systems. Or maybe it's your vehicle. A lot of those driving or car engine companies, they are adopting or using those sensor data to predict when the engine or when your vehicle gonna have some part of it disrupted or breakdown so that they can prevent that from happening and they will alert you before it actually happened. So those are the three most important categories that I think is in the fraud detection industry right now. And then, now after we talk about the categories for the fraud detection, I would like to talk about our general approach to how to build a fraud detection system. So here I call it a hybrid approach, and I really want to emphasize on this because I think for most of the data science problem, this rule can also apply, is you not only will need to apply your data science knowledge, your machine learning techniques to your model, to your business problem, but also at the very first place, we need to collect a lot of useful business insights from the subject matter expertise from your product team, your business team, to actually understand why you are doing this problem and if there is any specific knowledge that you need to acquire when you are building the model. And so here on the right-hand side with the yellow bullets, I have listed out the key steps that for building an automated anomaly detection or fraud detection system. The first one is rule-based business insights, which is we will always do a long or like a week-long or 2-week-long workshop with a client for their data SME, for their business SME to understand if they have any specific business rules, their business insights, what are the key factors that are actually impacting the current problems. And after collecting that business insights, then we will start to conduct a bunch of exploratory or statistical analysis for the aggregated data. And for fraud detection problem, the data sources we will be using would include the risk profile for their clients, the company information for their client companies, product usage, and all the other related data, if you think that will be relevant to the fraud detection problem. And after we collect, aggregate, and perform the EDA on the aggregated data, we will start to perform and conduct machine learning algorithms for the anomaly detection. So of course, we know if you have more data, the model performance will be improved. So when we set up the machine learning algorithm, we will always need to make sure that we set up as a structure that it will be very easy to incorporate new training data. And then the fourth one is deep learning algorithm for image analysis to capture fraudulent documents. So I think this is really applicable because a lot of those healthcare insurance or those claims, they are in PDFs. Or let's say if you want to do a receipt analysis, those are usually the pictures that's taken by the employee or taken by the business partners. So a lot of times we actually need to adopt deep learning algorithms for image analysis and then to capture the key information from those fraudulent or those pictures. And essentially, once we finish fine-tuning the machine learning algorithms as well as building the deep learning algorithms, integrating them with the business insights, we will start to evaluate with the business teams like how well or how effective those machine learning algorithms are. And also think about how we're going to deploy this into production environment and how the business team is going to use that. So this will lead to the automation of those routine processes. So think about how your current or how the current client company, they are processing all those different claims or their fraudulent claims. They usually will have a human intervention. They will have a case manager or some specific SMEs to look at the fraudulent claims or the claims that have been flagged as risky. And then they will actually look into those detailed information to decide or confirm whether this is a fraud or not. And then for us, I think it is really important to generate a probabilistic score for each of those transactions for each of those activities and send to the reviewer for approval. Because if you just send, let's say, oh, this is a fraud or whether this is a fraud, if it's a binary classification, if it's a two label, then it wouldn't give enough information for the reviewer. And then he wouldn't know how to prioritize which risky cases to approve first, which risky cases to approve last. So that will all depends on how the business team want to utilize your machine learning model results. And then based on their feedback, we will know what will be the best way to provide the machine learning model results to them, either through a UI or through an automated module to generate probabilistic score and rank them and send it back to their reviewers, or some other procedures that they would prefer. And then the final step would be we will create a real-time management system for those transactions or other similar decisions that they wanted to make. And here I've noted here, like the anomaly could be a fraud, it could be a problem or a mistake, or any specific product usage change that you want to monitor for your business. And now, since we talk about our generalized hybrid approach for how to build a fraud detection system, I would like to talk about the key techniques that we usually use when we build the machine learning models or the fraud detection system. And I have listed 6 key techniques, and feel free to reach out to me if you have any like specific questions about any of them. The first one I want to talk about is called supervised learning, which is the classification problem, is when your training data has a label. So for the fraud detection problem, that means when your data set already knows, oh, which is the fraud, which is not fraud, then you can actually train the classification model to determine whether the new transaction is risky or not. And then we can also split the data into training and test data set to see how it performs. But the only problem with this is for fraud detection problem, usually you only know what you know and you don't know what you don't know, meaning for the frauds that you have already detected, you know that part. But a lot of the frauds are not detected by the system, or it's not detected by the reviewers. So those frauds are actually the frauds you also wanted to predict out of your current training data set. But using supervised learning, you can only find the frauds that are similar to the frauds that you have already detected, but you will neglect the frauds that are not in your training data set. So this will lead us to the second technique, which will be the clustering, or we should call it unsupervised learning classification, is when you don't have a label for your data set. And essentially those different clustering algorithms are just looking at the data connections or the data features or the characteristics of your training data and trying to find if there exists like similarities between your different data points and dissimilarities between your data points. And then, so once you build the clustering algorithms, you will be able to discover the critical factors for the anomaly detection based on those underlying data patterns. And when you combine supervised learning plus clustering, maybe you will get a better performance of results to predict the frauds, because you not only capture the frauds that you already identified, but also you will be able to use the data patterns to identify the frauds that hasn't been captured by your system before. And then the third key technique, or we shouldn't really call it a data science technique, but I still want to mention here, is because as I mentioned in the last slide, it's really important for us to generate a risk score measurement for your fraud detection system. So if you only pass along, oh, this is our prediction, this case one is fraud, case two is not fraud, then the reviewer or the business user, they wouldn't be able to know why this was predicted as fraud or not. And also they don't know the probabilistic fact of like how likely is this case to be fraud or how likely is this case not to be fraud. And usually the business users, they wanted to understand the reasons why the payment or the transaction has a high or low risk score, so that in the future they can also improve their business process. And then they can also improve their way of reviewing those different transactions or activities. So building a model that will provide not only the risk score, but also the feature importance or the reasons why each case was given that specific prediction is really, really important. And we have a common word for that. It's called model interpretation. So recently, there are a lot of spotlight for model interpretation. I have seen a lot of bloggers or data scientists talk about it. And then I have also done a lot of research and projects around the model interpretation, because usually as consultants, clients will ask you to provide reasons for your machine learning models. And if anyone is interested, please connect with me offline. I can talk more about the model interpretation if needed. So on the next slide is 3 additional key techniques that I think will be important for fraud detection. The first one is image recognition. As I mentioned before, for a lot of those fraud detection cases, we will be dealing with a lot of PDFs, a lot of images. So that will actually require us to build deep learning models to detect the objects from those type of documents. For example, you might want to detect an image, a text, numbers, a table, whether that's a citation or not, those kind of things. And then once you build those deep learning models to detect those objects, you will also want to match the information that you have extracted from those deep learning models and then apply it to your analysis so that you will know whether this is a fraud or not. And simple use cases for image recognition will be receipt analysis, claims document analysis, or even financial planning document. And the fifth key technique is natural language processing. So once you have parsed a lot of text information, text metadata into your database or into the training data that you have been using, we would like to utilize text mining techniques to extract the patterns and those assertions or key topics from those large amount of text data. What kind of things is that specific document talking about? Is it a claim document, or is it a summary of benefits, or is it a legal notice that the company provide to their clients? So those are a bunch of use cases that we can think of when in terms of classifying the documents or to extract the key information from the documents. And the sample techniques could be like TF-IDF, n-gram, semantic annotations. There are many, many more natural language processing techniques that could be applied for this kind of problem. And the last but not least is time series analysis. So as I mentioned, if you are using a lot of product usage or IoT data, usually that will come with a timestamp, and it will record the usage at a different time frame for those specific users or specific techniques or specific devices. And then we actually need to conduct time series analysis to understand the trends, seasonality, and patterns of those transactions activities over time. We'll also compare the difference between the normal and abnormal transactions over time so that we can better understand their difference. Maybe they are similar during some of the time, but they are abnormal at some other specific times. And those are all need very specific investigation and understanding of the data across the overall time. And after I talk about the key techniques, Here on this slide, I would like to talk about a generalized architecture diagram for the fraud detection system. This is a simplified version. I also have a more complete one, and I also have published a bunch of different blog posts regarding how to build a fraud detection system from both business perspective and technical perspective. So if anyone is interested in reading that, please go to my company's website, indalian.com. And then if you click on the blog session, there will be a bunch of blog posts related to the fraud detection system. So here, if I just briefly introduce or briefly talk about the architecture for the fraud detection system, we always start with the database that the client have been using. Either it's on premise or it's a private cloud database. And then the database will contains like different information, including client profile data, risk profile, product usage data, billing data, and the other data that are related to the fraud detection system. And then once we understand their database structure or the technology they have been using, then we will start the ETL process. So meaning now we go to the data engineering pipeline, which is extracting the data from their database. And then we will merge those data sets based on their common keys. It could be their user ID, their time, their client ID, their device ID. It really depends on the level of the data that you are working with, but we need to be very careful when we match those data sets based on their common keys. If we make a mistake here, that will very largely impact the modeling results later when we build the fraud detection models. And once we have merged those data sets, we will perform a bunch of data aggregation, manipulation, based on specific time frames if needed. So this is referring to the time series analysis that I was talking about. And then essentially we will set up maybe batch processes or scheduler to schedule how often do you want to extract and perform those aggregation and merging for those different data sets. And once we have set up the data engineering pipeline, we'll go to the data transformation pipeline, which will contain, first, we're gonna extract the key features from the merged data. We'll also be dealing with the missing data and the incorrect data problem. So I think many of the data scientists have already talked about the importance of the data quality. If you put trash into your machine learning models, you will also get trash out of your machine learning models. So it is really important to make sure that the data that you put into your machine learning models is with good quality, no missing values, trying to reduce the bias of those missing values. And how you deal with missing value really depends on your data. You might want to be filling those missing values with 0, or you might want to fill in the missing values with the average value or the last value you see, or even just remove those missing values if needed. And then we will also perform the categorical variable conversion, because a lot of the machine learning models, they don't really take categorical variable as inputs. So we need to do that step too. And for numerical data, we might need to normalize the data or take variance for those different features, depends on the business needs or how you want to construct your different features for the input of the machine learning models. Once we have done all those time-consuming and complicated data transformation tasks, then we finally got to the stage of the machine learning model pipeline. This is where you do the train, test, validation, data split, and then we will build a bunch of data machine learning models and then try to optimize them with hyperparameter tuning. And then we will also compare the machine learning model performance based on the key business metrics. Maybe you guys want to focus on the AUC score, maybe you want to focus on the F1 score, or maybe you just want to focus on any other business metrics that you want to optimize. And essentially, the last step is to build the case management system. So again, for this step, you need to negotiate and discuss with your business stakeholders for this project to understand what will be the best way to help them to utilize the machine learning models, whether it's a ranked list of all the risky cases or risky activities that you could provide to them, or maybe they even want case-by-case level of understanding why that specific case has been assigned the risky score of 0.9 or 0.5. And then also, they may also want to know if there's any way to prioritize, or how many cases, how many risky cases will you be providing to them can also control by your machine learning model, whether you want to include more risky case or whether you want to focus on the accuracy when you predict the risky cases. So all of those steps, I feel like they will happen in an iteration. If you find problem or you find there will be a room for the improvement for each of those modules, then the data scientist or data engineer will go back to the problem and go back to that specific module to check and to improve that specific module. So essentially, when you build those modules, they could happen parallelly or sequentially, but you will always want to make sure that you maintain your code base and your modules effectively so that it will be very easy to revise and improve any part of it. And now we have talked about the general approach of how to build a fraud detection system. I would like to talk about the key drivers and challenges that I faced while I was working on those different fraud detection projects for the clients. So the first one I would like to talk about is the key drivers. And I think those I have already talked about during my last several sessions or last several sections. The first one is the input data quality. Always make sure to improve your data quality before you are training the model, and check very carefully if you are missing any specific data or if there's any incorrect data. And then when you go to the model performance fine-tuning it based on the specific business needs. Don't fine-tune it with your data scientist philosophy or whatever you think is important. What's more important is how the business users, they will be using the results and what business metrics they care about the most. So we definitely need to integrate their feedback and their suggestions while we were fine-tuning the model performance. And then the so one actually echoes with what I said is if the business part thinks, oh, maybe you need to integrate the complaint data, or maybe you should integrate the blah blah data that we have collected newly, then try to do it to see if it will give a lift to your current model performance. And then another topics that I have actually presented at other conferences, or I always talk about with my clients, are called model performance monitoring. Because in the production environment, you always want to make sure that the performance of the model will be sustainable and stable. And then when you are deploying new versions of your machine learning models to the production environment, if there's a big change, then the system should automatically do a test to see if there's too much of a model performance drifting, so that it will alert the data scientists to check on what's going on with the current newly model comparing to the historical models. And then the system should also check the input of the training data and compare it with the historical training data to see if there's a big change in the training data. And then essentially, once we monitor the model performance, then we will talk about the model interpretability, which is how you explain to the business users or those product owners why the models are making that specific predictions. And then for a lot of those financial institutions, it's legally required to interpret or to provide the reasons why those models or how those models are giving those specific reasons or giving those specific predictions. And then in addition to all those key factors or key drivers, I want to talk about another key important thing that's really essential for data science model deployment. So I think everybody is pretty familiar with the phrase DevOps. And then there are a lot of like DevOps, different levels of DevOps maturity. So this will come from like source and build control, like how you manage your source code, how you do the continuous integration, or how you build your codes and then containerize your application. But then and the next level, we should also think about like when the model has a problem, or when you have a new release for the machine learning model, how you're going to manage that process. And then the next level 3 is security and compliance. Is how secure is your current system? How secure is the way that you are extracting the data, transforming the data, and sending the data to the business users? Level 4 will be operations and business continuity. So those will be, okay, when there's an incident or when there's a problem for your application, how you're going to manage that. And then the final level is continuous delivery. Is you're going to automate all those deployment tasks and downtime deployment process. I mean, I think for data scientists, inevitably, we will start to know more and more about how to develop and deploy those data science applications from the um, development environment to the production environment. So we will get more and more knowledge about the machine learning operations. And it is really important for us to keep those concepts in mind so that our data science application could be very stable in the deployment or in the production environment. And then the business users can actually gain true benefits from our application. If we don't have a stable data science application in the production environment, then it will be very hard to see the value or gain the value from the models that we have built. And on the next slide, I have talked about 3 more challenges that we always face. Data quality issue, which I have addressed. I wouldn't spend more time on that. Imbalanced data set, which I also about in the last several sections, is for the fraud detection, only a small percentage of the customers has fraudulent intentions or has been detected have conducted fraudulent activities before. So when we train the machine learning models, the imbalanced training data set will actually lead to very high prediction bias and poor predictive performance. And we will need to think about different data science techniques to balance the data set to improve the prediction results. And the third challenge will be the changing fraud patterns over time. So people are always trying new ways to get around the system to commit fraud. It is very important for the machine learning algorithms to continually to be retrained and updated based on the latest data so that we will be able to identify the most recent fraud patterns. And now I have talked about the general approach as well as the key factors and challenges. I would like to talk briefly about one of the use cases I have worked on before. And because this is client project, so I will only disclose very limited information. I can talk about all the technology, but not really a lot of the business information. So for the project, we actually helped a first-tier bank to develop a data science solution to detect unusual transactions. And then we also helped them to automate the account behavior monitoring process. So the data we use is the transaction data, which will include, okay, the currency, the amount, the recipient, the text message when they include in the transaction. And then we also use their client KYC data, which will include client type, industry, KYC rating, region, and etc. So essentially, how we build the fraud detection system is we build a lot of unsupervised learning models to segment the clients into different customer groups based on their like characteristics as well as their usage. And then we label the transactions within each of those customer groups based on our anomaly detection algorithm. And then because for different individuals or for different clients, we were also checking the data quality. For some newer clients, we don't have that much transaction data. So we actually need to set up a separate model process to predict for those newly individuals. And then for the individuals that has enough transaction data, we have another model to do that. And I think for a lot of data science problems, you should always be aware that like for your new customers, you should always set up a separate data model or machine learning model, and then combine it with the other machine learning model that you have for the users that have a lot of data. And essentially, the outcome for this project is really, really good. We were able to improve their efficiency and accuracy of their anomaly detection. We were also able to help them to identify a lot of fraud detection or fraud cases that they haven't been able to detect it or label before. And then we were also helping them to understand the patterns and the key indicators for their fraud detection system. So for the next slide, I want to briefly talk about the algorithm that we use for the anomaly detection, which I think is really good. For anyone who wants to build a fraud detection model, please try this algorithm. It's called HDB scan, which is a clustering algorithm, a density-based spatial clustering. And then, so the benefits of using this algorithm is it's not only able to break down those individual cases into different clusters, but also it's very noise sensitive. So it will also help you to predict the outliers, meaning the transactions that are just noise, which is not normal, but also not abnormal. It's just noise lying in the data set. And then on the left-hand side, the graph is just showing like once you have built the sample clustering, and then all those colored clusters are the clusters you have, and then the gray dots are the noise. And on the right-hand side, for those black dots, you can see some of them just black because they are classified as noise, but some of those dots are labeled in color, meaning they are classified into each of those clusters. And this algorithm is also has implement the soft clustering, meaning they will be able to provide a probabilistic score for each of those classifications you are making. They will tell you, oh, this has a score of 0.7, meaning, oh, I mean, I think conceptually you can say 70%. The reason why the dot has been classified in this cluster has like 70% of probability, which aligns with the goal that I talked before. Is you always wanted to associate a risk score with your prediction or with your classification. So please do try out if you have time. I really recommend this clustering algorithm. And then now I would like to talk about the key conclusions that I have reached. So first, there are many different kind of business applications for fraud detection, including financial transactions fraud, detecting healthcare claim fraud, as well as monitoring sensor data fraud. And then secondly, it is very important to incorporate both the business insights and the machine learning model results into your fraud detection system. I believe a hybrid approach will provide the best performance for your machine learning models. And then the third is make sure that the input data of the machine learning models has good quality data, and always remember to use proper techniques to deal with the imbalanced data set problem that you will be facing for fraud detection problems. And that's it for my today's session. Thank you. I'm open for questions right now.
Hi, Meina. Wonderful talk. So we have a few questions. The first one is, I don't quite get the point about fraud detection for sensor data related to machine maintenance and monitoring. Are there real world cases that you have worked on?
Um, So the point of for the sensor data, yes, I mean, we are currently in discussion of a technology company which is concerned about uh, the building management. So for building management, you can have alarm data, you can also have the heating system data, and then the alarms can be triggered falsely or positively. So and they will, and different alarms can trigger other kind of alarms. That means it's really important, or it will be very useful if we can use those sensor data or those building data to predict or to at least understand the patterns why it's triggering different alarms, and then whether it is a false alarm or if it is a positive alarm.
Right. Sounds good. So the next question is the rules system is a database about the knowledge. How to modeling it? Is there some tools?
The rule system is the are you talking? I mean, I don't quite get your question, but I guess you're just referring to how to integrate the business knowledge from the business side. Um, I guess essentially depends on what kind of data or what kind of information are you getting from. Is it a factor? Is it a key factor? If it's a key factor, then you need to think about whether you will be able to collect the data. For example, if let's say the business want to understand, oh, if there's any social media attitude change for our product, then you might need to collect the social media data and generate a sentiment analysis score for your product, right? But if it's just hard-coded rules, let's say, oh, if the transaction is happen more than this frequency with this amount and happening from this region, then those will just be straightforward hard-coded rules. And the only thing you need to decide is how much weight do you want to assign inside your model.
Sounds good. Yeah. The
Mhm.
next question is thanks for the talk. I would like to know what technique is used in handling data imbalance in fraud detection.
There are many like different for I guess model imbalance techniques. You can uh undersample the majority class. You can also oversample the majority class. The most quick ways you can just duplicate, or you we also have a lot of like different data simulation package which will help you to generate like similar data set. So you can actually simulate the minority class and then add more to the class, or you can just straightforward like when you do a random selection of the majority class and then combine it with the minority class. So depends on your data size as well as like how good the data simulation performance could be. And then you should also try with those different techniques when you are building the models and and compare the model results.
Yes.
Oh, and one more thing is there are a bunch of like classification algorithms. You can actually assign the weights when you are predicting the classes. So you can assign a heavier weight for the minority class if you want to focus on the minority class. Yep.
Yeah, such as random forest, right?
Yep. Yep.
Mm-hmm. Right. So the next question is what new trends in fraud detection do you see emerging with the increase of online activity and e-commerce sales during COVID?
Yeah, I think I can see like because a lot of like online payments or transactions, so definitely the financial institutions will put more focus or put more money on investing on that. Another thing is identity theft, right? How like when you want to open an account or when you want to do some like super sensitive actions or activities online, usually that will check your identity, and how to identify whether you are the person or not could be another application for that. Mm, and then I think, yeah, I think that's pretty much it. And other than that will be the healthcare claims, because they will get a lot of healthcare claims because of the COVID-19. Yeah,
Good.
I'm sorry to say that, but that's the truth.
Yeah. So the next question is hi, Meina. Your talk is really impressive concerning the bias of prediction caused by imbalanced dataset. Would you choose the smaller cut point threshold such as zero point 0.3 instead of zero point 0.5 for prediction a years? Could you give some example? How do you deal with imbalanced dataset?
I think I talk about how to deal with the imbalanced data set, but your question here is more like, it also touched the point that I talk about is how many suspicious cases that you want to provide to the reviewer team. And it also depends on their workload, right? If they say, oh, we only want to review 1,000 or 10,000 cases every day, then you will, when you train the model, you will balance your precision and recall rate based on that specific threshold. So it's really like business to business.
Yes, got it. So, which Python libraries do you find very useful for fraud analytics?
Hmm, I think for Python libraries, it's like NumPy, SciPy, scikit-learn, and I also talk about the specific algorithm that we use. It's called like HDB scan. But definitely you need to try different machine learning algorithms or different, like either supervised or unsupervised learning to see what fits your best, or maybe you do a combination. So I will recommend you to try a lot and explore and research a lot.
Yeah, yeah, that is the best option. Try
Yeah.
everything and then figure it out. Okay,
Yes.
so yeah, we have one more question, but unfortunately, we are running out of time. If you have few
Mm-hmm.
minutes, please just try to answer the question in Q&A section.
Mm-hmm. Okay. Yep. Will do.
Yes.
Thank you.
And we are grateful for your time and effort. Your presentation was really informative. We got to learn a lot how to do data analysis, how to start, and how to end the project. Everything you covered pretty far is absolutely marvelous.
Thank you. Yeah. Happy to be here. Yeah.
Thank you, Meina.
Yeah. Bye.
Bye.